Wonder how you build a robot? Wonder how you teach a robot? Wonder what it's like inside a computer?
Ever wonder why? I sure do. Wondering why things happen is the first step to discovering the world around us. Today we'll explore the fantastic world of computers and robots.
Willy Wonder here. Wonder what brain fits on a crystal flake?
This is Steven. His mission for Wonder Why? Travel the waterways to the jungle ride at Disney World and take note of all that he sees. He had better not forget to watch out for the elephants. They won't forget seeing him. Elephants never forget. If he stays cool and doesn't muss his hair, he'll be okay. Hippos potamus. You could say they go ape. A little jungle humor there. Look, Stephen, no cavities. What Stephen doesn't know, but will soon learn, is that all the animals and people he is seeing are not real. They are not alive. They are really computer-controlled robots, even the dreaded headhunters.
And so, the robot headhunter Susie was captured and made into a robo-windshield assembler in Oshawa, Ontario. And everyone lived happily ever after. The end. Gee, what a story. I love robots. Ever since I was littler, I've wanted a robot of my own. But I've always wondered, how do you make them work? How do robots know what to do?
We have a computer that tells them what to do.
Are some of them scary?
Yes, we have some that are purposely scary, like in the Haunted Mansion.
I've been there.
You like that, the ghosts in the Haunted Mansion?
Are they dangerous?
No, we don't feel they are, as long as they're properly controlled and maintained.
What is that?
This is our dog, Daxie. Let's see if we can make her work. We have a person who will put the animation in using a computer into the memory so that when we ask the dog to perform, it will play back and do its performance. Computers are very important to us at Disney World.
Why do you call it Daxie?
Well, that's the name of this computer area. It's called DAX. So we just put the dog's name as Daxie.
Thank you.
You're welcome.
I have decided to build my own robot, but I think I'll need some help. Richard, how do you build a robot?
Well, that depends on what kind of robot you want to build. When most people think of robots, they think of something that looks human-like. Well, in actual fact, that's an entertainment robot. Real robots, like industrial robots, look completely different. And they do jobs that are either too boring or too dangerous for people. Here, take a look.
Are those really robots?
Well, they may not look like robots, but they actually are. And you know, all robots have certain things in common. For instance, they should have a moving part, like an arm to do jobs with, like spray paint or weld.
How do robots know what to do?
Well, a robot has a brain to control everything, and a robot's brain is a computer. That's another thing a robot should have.
I guess I was thinking of building a human kind of robot.
Well, I'm just a regular scientist. I'm afraid what you'll need is a mad scientist.
The word robot was first used by a Czechoslovakian writer named Karl Čapek. The Czech word robota means slave-like work. Čapek wrote a play called Rossum's Universal Robots. In the play, artificial humans, made of metal but with no human feelings, are built by Rossum on a faraway island and are sold all over the world to do slave labor for humans. Eventually, the robots rebel against their masters and take over the world.
Scientists. Let's see. Regular scientists? Upset scientists? Very angry scientists? Ah, here we are. Mad scientists. Dr. L. Luzardo II. Robots of specialty. PhD, BEd, BUG. 1313 Liberal Lane. Dr. Luzardo? Dr. Luzardo? Are you in here?
Ah! The check's in the mail. I'm broke. Look. A few bugs to iron out. Need salt.
I'm not here to collect money. I want to build a robot.
Robots, right. Well, you came to the right place because I build robots. Here, keep your eyes peeled.
Do you really build robots?
Hey, do androids dream of electric sheep? Can you read?
Sure.
Well, that makes one of us then. Read this.
The proper care and feeding of robots. Chapter 1. The moving parts. Arms.
Arms. I'm up to my neck in arms, so to speak.
I got a bad feeling about this.
No, wait, I'll build a robot. Once I figure out how. It'll be a robot such as the world has never seen. An all-powerful force of ultimate evil.
I just want a nice, quiet robot to play fish with.
Sure, an all-powerful but quiet, ultimate fish-playing robot. That's what I meant.
And it shouldn't win every game.
No, sure. An all-powerful but bit of a loser, ultimate fish-playing robot. Thrilling. Typical. The lizard of pure science selling out again to small-minded, small, capitalist co-hosts.
We'll find out how to teach a robot and watch Tilden Plodner create a force of ultimate evil. But wonder why he returns.
Did he say Tilden Plodner? My brother?
The first phase of our robot is complete. Robo-arm. Okay, arm. Pick up an egg. Softer, you fool. Not too soft, not too firm. Ah. Hurry! Find out how you teach robots.
Becky, can you find out how to teach a robot?
You're not getting into any kind of trouble, are you, Tilden?
What kind of trouble could I possibly be getting into?
Like, you're not thinking of building your own robot and unleashing ultimate evil upon the world or anything.
Listen to yourself. That's ridiculous. I just have a very inquiring mind. Wondering why things happen is the first step to discovering the world around us.
Why do I have a feeling he's not telling me everything?
How do you teach robots?
I think you teach it by programming it on a microchip. I think there's a little machine inside and it makes it work.
Bob, I see not a whole lot of people around here. I see what I think are robots. Can you tell me what robots are? What you do with robots here?
Well, these are industrial robots that we use to perform a lot of the operations that men did when we had formerly what they call a jungle line, which meant we had cables running from all the well guns. Now the guns are held by the robots, and and the robots perform the operations that the men did. We still have a lot of people here, but they're not quite as evident. The people that we have here today are the skilled tradespeople that keep the robots operating.
Why do you use robots instead of people?
Well, the robots add to the quality of our vehicles, mainly because a robot welds in the same spot every time. He doesn't bend his arms, he doesn't move to the right, he doesn't move to the left. He puts the spot in exactly the same spot every time. A car will pull into a robotic station. The robot, through the computer, realizes exactly what model of car, a two-door, a four-door, a Buick, or a Chevrolet. It then coordinates the proper movements and the proper weld sequence on that vehicle. When we first went to robotics, we used a fair amount of hydraulics, but we have since moved to electronics.
What kind of jobs do these robots do?
They do the welding. We use them in different applications. We have some that do some painting. We have some that load windshields. We have some that check the welds and the dimensions of the car.
Thanks a lot, Bob. Really appreciate that.
Quite welcome.
I know this isn't a real robot, but robots are neat. But how do you teach them what to do?
Well, why don't we pretend that I'm a robot, and you give me a set of instructions to pick up that pen, let's say.
Okay, pick up the pen.
Doesn't compute.
Must be a slow learner. Raise your arm.
Doesn't compute.
I can't seem to teach you.
That's because robots aren't very smart. If you or I wanted to pick up the pen, we could just lean over and do that. But just think how incredibly complex even the most simple act is. For instance, my brain needs a signal. That's your voice going into my ear. My brain deciphers what you say. Then it has to decide which muscles to move in my arm. And my arm can move about 40 different ways. It can move up and down. And
So, robots have to somehow decide which parts to move. That must be rough.
well, yes it is, but even the most sophisticated robot can only move about 6 to 10 different ways, so that helps the programming a little bit. You have to program each individual movement that makes up the entire action.
I get it. Okay, raise your forearm. Okay, stop. Now lean forward. Turn your arm a little to the right. Okay, stop. Now lower your hand. Okay, now close your fingers. Okay, now you can raise your arm. So when you want to... Okay, you can stop now. Now lower your arm. Okay, I'll take the pen.
Okay.
So when you want to teach a robot, you have to take it through step-by-step instructions.
Right, but after it's done at once, it can do it again automatically as many times as you want. The instructions have been stored inside the robot's memory or program.
Okay, pick up the pen. Richard Zarowski, robo-host.
Exactly.
I think my brother Tobin is fooling around with robots. I'm afraid his robot might get out of hand and terrorize the planet type of thing. Do robots know what they're doing?
Well, most advanced robots have some kind of feedback device or mechanism, something that tells them what's going on around them. Human beings have their own feedback devices. We call them senses. If you want to pick up an egg, you reach out your hand and use your sense of touch to know how much pressure to use to pick up the egg. Too tight and you'll crush it. Too soft and you'll drop it.
What kind of feedback devices do robots have?
Well, let's see. A welding robot would have a sensor in its joint to tell it at all times which position its arm was in so that it could actually do the welding in the same spot over and over again. So it would weld one spot without making a mistake and then could move to another spot and do the same weld.
So that's what I've learned about making robots, Tobin.
Great! We'll be able to make a robot now.
I know a nice robot maker who could help us.
I've already found a robot maker.
Is he an accredited scientist?
Are you an accredited scientist?
The cyborgs floss with chicken wire? Relax. I got everything under control.
Tobin! Tobin? Tobin!
Still wondering what brain fits on a crystal flake?
We have a body. What's next?
Chapter 11, the brain. Every good robot deserves brains.
A brain. Now where am I going to find a brain?
We'll take a fantastic journey inside a giant computer and watch as Dr. Lazarda II and his evil henchmen...
Not evil, just misguided.
Evil henchman, Tilden Plodner, unleash the ultimate but bit of a loser robot on an unsuspecting planet.
He should never read to himself before he goes to bed. He gets too excited.
What do you know about computers, Renfrew? Well, the father of the computer was Charles Babbage. Babbage thought he could build a machine that would solve number problems. He called it the difference machine. It had hundreds of metal rods, gears, wheels, and weighed tons. The only problem was, it didn't work. But the idea caught on. Fascinating. But I need to know about modern computers. We could call Question Mark's cousin, Mark. I hear he has an IQ even higher than mine. He's always reading magazines, pamphlets, instruction manuals, books of every type. In fact, he reads so much they call him Bookmark.
What's it like inside a computer?
Can you find out what goes on inside a computer? There's only one way to find out. Fortunately, I live in Boston, not far from the only computer museum in the world. Hey, over here. I didn't shrink. I'm in a giant-sized computer in the Computer Museum here in Boston. And Dr. Strimple is going to show me what goes on inside a computer. Dr. Strimple, could you please tell me how a computer works?
Well, I'll try. The best way to understand how a computer works is to use one. Now, we're standing here in front of a part of the keyboard of this giant computer, and we've got things set up so that if you press one of these keys, it'll send some information inside the big computer that will tell it to start running a program, and then we'll take a look at that program. So why don't you go ahead and press a key and we'll see what it did.
Okay.
Okay, let's go and take a look. Okay, now we're walking inside the computer, and everything here is 50 times life-size what it would be in a normal computer. Now, when you press the key, the information first would come to this chip here. This is the chip that takes the information from the outside world and converts it into a form that the computer likes. In fact, it's sending it in parallel along all these wires here, communicating very, very fast with this here. And this is the heart of the computer. This is the processor where everything really gets controlled. It's sort of like the brain of the computer.
So can computers think?
Well, they don't really think like people think. They get things done by doing things very, very fast. Millions of instructions a second. We only do things about 1,000 times a second. It may seem slow, but actually we get a lot done each time. Here, these are very, very small instructions. Now, what the computer is doing, what this chip is doing, is it's controlling everything inside the computer. It's like the computer's resources. It uses this ribbon cable here to communicate with its hard disk drive, which is one kind of memory. And the lights along the floor show how it communicates with another kind of memory, the random access memory, where it gets the instructions that are inside its program that it's executing millions of times a second. Each of the things you see here flowing inside the chip is a separate instruction that gets the computer to do what it's supposed to do. Why don't we go and take a look at the memory and see where these instructions come from? Okay, this is the memory that stores all the data and instructions that the computer needs. And as you see, it's a row of chips. And if you were to cut a little hole inside the chip and see what was going on inside, you might see something like this going on, where you have the hand, which represents the processor we just had a look at, fetching all the information it needs, grabbing it and taking it straight back to the processor to execute it. That's the program. Now, there is another kind of memory called the hard disk drive. And let's go over and take a look at that. As you can gather from the name, it's actually made up of disks, in this case about 8 disks, and they have information on them stored as patterns of magnetic charge. And the information is read off by heads that scan to and fro, looking for the information on the disk that the computer needs. This kind of disk is actually slower than the other kind, but it can store a whole lot more information.
Why are there 2 different memories?
Well, one of the main reasons is that this kind of disk, this kind of information doesn't disappear when you switch off the computer, whereas that kind does. As soon as you switch the power off, it's all gone. So this is permanent, and that's very important because you don't want the computer to forget everything you've told it when you switch off the power.
Thank you. What are computers good at doing, and what are they used for?
Well, computers are good at doing lots of different things. One of the most widespread uses is actually using a computer instead of a pen. It's called word processing. Every time you write something, instead of using a pen, you can type it into a computer, and then you can change it and edit it and play with it without ever having to scratch something out and make it look messy. Computers are very good at handling numbers. You can use them to help do taxes and budgets and things like that. You also find computers inside lots of things you buy nowadays, such as microwave ovens or video recorders, where they act as little controllers that help you program things. And of course, they're also used inside robots, where they really act as brains that control the robots and tell the robots what to do and store programs and instructions so that robots can behave intelligently.
Thank you, Dr. Strimple.
You're welcome.
Now I know what goes on inside a computer, but I still don't know how a computer's brain works.
Richard, what's a computer's brain?
A computer's brain is the silicon chip. It can be as small as your fingernail, but it can do some amazing things. Not only run computers like the one we saw in Boston, but, for example, my watch. It has a computer chip in it that counts seconds, minutes, hours, even the date. There are computer chips in cars that tell us if anything's wrong by constantly monitoring the engine and the various systems in the car. There are even computer chips in toys. They're just about everywhere these days.
How does a computer chip work?
Well, a computer chip works a little bit like your brain does, using electricity. In the brain, we have millions of cells. Information fires around between the cells as electrical signals. A silicon chip is made up of millions of wire pathways and gates, called transistors, that we send signals through. The signals are lightning-fast pulses of electricity. The pulses move along the wires, and depending on the type of pulse, the gates let them through or not. The result is a special type of computer code.
Kind of like a Morse code, turning lights on and off to send a message.
That's right, except millions of times faster.
What kind of code do we use to talk with computers?
We don't use regular numbers or letters to talk to computers. Instead, we use what's called the binary system. There are only two numbers in this system, 0 and 1.
Sounds simple enough.
Depending on where the zeros and the ones are placed, you can make them stand for numbers or letters, just about anything you want. So, a 1 means yes, go through the gate. And a 0 means no, don't go through the gate.
So, all those ones and zeros become electrical pulses that travel through the pathways in the computer chip. And the tiny, tiny gates in the chip let them through or not. And that makes a computer code. Simple.
Well, I'm glad you think so. But to figure out how a silicon chip puts all that information together would take up a whole other show.
I have enough for now. I better go tell my brother. Thanks, Richard.
Still wondering what brain fits on a crystal flake? The answer is the silicon chip. Silicon's a kind of crystal.
Till then.
My brain! Slightly large cranium, so I can trim it down to size.
I don't want to use his brain, just the stuff inside it. About computers.
It's too late. The process has already begun. When I throw this switch, the computer will be electrically transported into the robot's brain. Ultimate evil will be unleashed upon an unsuspecting world that will tremble at the name of Dr. Lizardo II.
Ultimate evil?
Did I say ultimate evil? I meant ultimate fish playing. Let's get out of here. It should be ready. Now, let the world tremble.
I got a bad feeling about this.
Meddling human-type person? But it's too late. It lives! Robot, get up and go take over the world.
Actually, I prefer to work at home.
I gave you a command. Me, your master.
Use the objective case me to modify the genitive form of the noun and not the nominative singular pronoun such as I.
What have you done to my baby?
Well, that's our show for today. Remember, there is so much in this world to discover, so be curious, explore, and keep wondering why.
Wonder why rocks get so hot they can melt? Join us next week when we explore the wonder of volcanoes.
I'm through. I'm finished. I'm hungry. Are you eating that?
Be my guest.
Need salt. Very nice. 1987, I think. Green Chardonnay.
Can you fry fish?
ראשון הבא בערכו לנשים.
Heaviest bombing in Europe since World War II, NATO's air